quick review on dilations because similarity has to do with dilations, okay? You have to have a dilation to get a similar shape when we're using transformations to make new shapes. All right, so we have the identical shapes. These are congruent. We would use a translation to slide A and B and C all over there. But that's not what we're focusing on. We're focusing on just taking this shape, triangle ABC, and we're going to dilate it, okay? And we focused more on dilating from the origin, but this video is going to focus on dilating from a certain point. So we'll first focus on dilating from point A. All right, that's like your anchor, and everything's going to move away from that anchor point. All right, A is going to remain stationary, right in the same spot, and everything's going to move away from that, directly away. And they're going to move, how do you know how far? Well, we need a scale factor. So this first one, we will focus on doing a scale factor of 2, all right? Scale factor of 2. So the distance away from the center of dilation is going to double, right, or multiply by 2. Now, in dilations, anything that is either perfectly vertical, like C is, or horizontal from the center of dilation is going to be a lot easier to move than, say, B, which is diagonal away from the center of dilation. All right, but the key is, let's start with C since that's the simple one, and we will just count up how far it is away from the center of dilation. It's 1, 2, 3, 4, 5. So how far is it going to be after a scale factor of 2? So 5 times 2 is 10. So there's to C, and then we need 1, 2, 3, 4, 5. All right, so that's where C prime is going to be. And the more difficult part is figuring out where B is going to end up. So I'm going to bring in another color here. Let's do a little light blue. So B is diagonally away from A. So that makes it a little bit trickier. Now this one's kind of nice because it cuts through blocks perfectly from corner to corner. It's like a diagonal for each block. And so we could kind of see, oh, it's diagonally through 2 blocks, so now it's going to be diagonally through 4 blocks. That's a little dangerous because it won't work all the time like that. So what we're going to need to do is find the horizontal and vertical lengths away from the center of dilation. So it looks like we go 2 over and 2 down. So with a scale factor of 2, we're going to double both of those, and we're going to go 4 over and 4 down. All right, and there we have our B prime. So let's get the red and the line, and let's draw our line into B prime. All right. Now, we don't have to do much else. We're just going to connect those dots. All right, and that's the key. Okay, so any diagonal lines that have to be scaled, we can just find the horizontal and vertical distance from the center of dilation and then operate the dilation or the scale factor on those lengths and draw our new lengths and find our point. All right, so the next one, we'll pick a different point to be our center of dilation. All right, we'll pick point B, and I picked point B because it doesn't have any vertices that are horizontal or vertical from it. So it's a little bit trickier. We're also going to do a dilation of 1/2. 1/2 is going to shrink the shape. All right, so A is going to be half the distance away from B that it was, and C is going to move to half the distance. Now you can kind of eyeball where it's going to end up if you're used to this, but we're going to do it a little bit more mathematically. Again, we're going to have to find the distances, the vertical and horizontal distance away from the center of dilation. So we're going to say, oh, look, A is 2 up and 2 over. So if we multiply both those lengths by 1/2, we're going to get 1 up and 1 over. All right, so then A prime is going to end up being right there. All right, so now we have B to C. So if we look at the vertical and horizontal distances, that gives us a vertical distance of 3 and a horizontal distance of 2. So multiply both those by a half, and we get 1 and 1/2, 1.5. Right, half of 3 is 1.5, and over 1 full block to right there. All right, so now we have our new points, our image points, and we can connect those and get our similar triangle. All right, so similar triangles have equal angles, corresponding angles are equal, and corresponding side lengths are proportional. All their corresponding lengths can be put into ratios, and all those ratios would be equal. All right, so there's our quick review on dilating from points other than the origin. All right, good luck.